Hello everyone, welcome to join us with this AP Computer Science AP level video. In this video we are going to discuss with you about questions 23 until 29. Question 23 to 25 are based on the following procedure, which copies items from an array ARR containing n distinct numbers into a binary search tree called tree, and then prints the elements. So the following is the 3 steps of the procedure. In step 1, we initialize the tree to be empty. In step 2, we insert ARR0, ARR1, ARR2, and so on until ARRn-1 into tree using a standard algorithm for insertion of item ARRI into tree, and we assume that the insert operation does not balancing of tree. In step 3, we print the elements stored in tree and using an in-order traversal. So basically that means after we build the tree, all those n elements instead of the original array ARR from index 0 to n-1, index n-1 has all been inserted into the tree, and by our assumption of a binary search tree, it will be organized very well. What does that mean by organized very well? That means if there is an internal node which has 2 subtrees, left subtree and right subtree, then the internal node of the left subtree and also all those nodes belong to this left subtree, including its leaves, will have value less than or equals to such an internal node. On the other hand, for all the nodes belongs to its right subtree, their values will always greater than or equals to the value of this internal node. Yeah, that's what we mean by the organization of this binary search tree. Now let's check. The step 3 says that after we inserted all these elements and elements into the tree, we print the elements stored in tree and using an in-order traversal. Now let's check question 23. Which of the following best characterizes the output produced in step 3 of the above procedure? There are 5 choices, but from step 3 we know that we want to do some in-order travel. So what does this in-order traversal? Remember that the in-order traversal, basically there's some rule. First, left subtree, then internal node, then right subtree. And such kind of recursive procedure goes on and on as we traverse through the whole tree, especially in this binary tree. So that means if we use an in-order traversal to traverse a binary search tree which has been organized just by the original insertion, we will have the following results. That is, the choice B, the items are printed in a sorted order from smallest to largest. Why is that? Because from our previous discussion of the property of the binary search tree, for all those nodes on its left subtrees, they have values less than the internal node. So which means that we can assume that the group of those nodes in the left subtrees, before we sort out the sequence of them, at least we know that roughly all those nodes which has values less than the internal node, that means the root node, then for those nodes belongs to the right subtree of this internal nodes, they will have values which is always greater than or equals to that. So that's why the items are printed at least in roughly, they will be in a sorted order and from smallest to largest. For the same argument, we can continue to apply for the left subtree of this root node and also the right subtree of this root node. We just substitute the root of the left subtree and also substitute the root to the root of the right subtree, and using the same argument, we know that this traversal of the whole tree in order will make sure that the items are printed in a sorted order from smallest to largest due to the good property provided by the binary search tree. So the answer is B. Now, question 24. Which best describes the best case runtime of the whole procedure? We have 5 choices: big O of 1, big O of n, big O of log n, big O of n log n, and big O of n squared. So which best describes the best case runtime of the whole procedure? Let's check. We know that after we do the traversal, every traversal we might have, in the worst case, to traverse from the root to the leaves, right? So that means if it's a balanced binary search tree, which might take log n, because the depth of a binary search tree of n nodes is log n, and we might at most have to traverse so n nodes belongs to this binary search tree. So we multiply two factors n with log n together. That will make sure that the whole procedure will at most use big O of n log n runtime. So the answer is D. Question 25 asks another distributions or properties of the data that will best fit to our data structure and also the algorithm. It mentions that the procedure is most likely to exhibit its best case runtime when the numbers are stored in array ARR in which of the following ways. The first choice is in ascending order, the second choice is for the descending order, and the third choice is for the random order. So what will be the best answer of that? We know that if it has been inserted in ascending order, it will be very, very easily to build a skewed tree, because at the beginning, the root will have the items which has the smallest value. Then after we inserted the second element of this array ARR, that means ARR1, because the values of ARR1 is greater than ARR0, so which means that this ARR1 will be inserted to the root of the right subtree of the original root. And so on, ARR2 will be its right subtree, and ARR3 will be the right subtree of ARR2, and ARR4 will be the ARR3's right subtree, and so on, the root. So that means in ascending order, there will be some right skewed binary search tree build. And if you check by our discussion logic earlier, the descending order will build a skew tree, but this time it grows leftwards. So, which means that the most likely to exhibit its best case runtime when the numbers are stored in the array ARR in random order. In a random order, we probably could guarantee that the binary search tree will be stored with height big O of log n, which is good, and which will let us to take advantage of the binary search tree. So the choice will be C. Now the following are questions 26 and 27, which are based on the computable interface and the large int class shown below. Okay, now we see the first part is the interface, which is called computable. For this computable interface, it defines 3 methods for the operation for one object. So it has inputs of one object which has reference name obj, and it will return another object of the same type. The same thing happens for the subtract. It received the input parameter of an object called obj and returned another object belongs to the same type. The same for multiply. Actually, that means that we will return the object times object. Okay, now the following is a very simple public class which is called large integer, which implements such a comparable and computable interface. Note that the comparator interface means that the elements for them they might provide the comparison methods for uh, objects belongs to the same type. And for the computable, we have to implement add, subtract, and multiply. So for this, it might contain some private instance variables, but as we trace down the whole class, we know that all those three methods that has been mentioned before, the add, the subtract, and the multiply, will be implemented. Now, there are also several different methods that belongs to the classes large int. For example, pop large int of input, and this is a constructor that will convert into large int because this is the basic type of a class that we need to build by the any possible input parameters belongs to a small integer. We have to convert it into a large integer. Okay, then after that, there is another method which is also some fundamental method needs to be done because these fundamental methods will be very useful later on when we try to discuss about the implementations of this computer interface, the add, subtract, and multiply. Why do we need this toString, which will return a string and which is a public method? You just return this large int as a string. Why is that? Because this may be useful for debugging purpose. Because this is a new class of data structure that we just defined before. If you want to compare, if you want to check what goes on during the middle of the operations, the easiest way is to print out. But since we just defined a new type of class, we have to make sure that once we print out the content of this class will be not some scrambled, unrecognized, ambiguous symbols, but just a very clear and succinct information represented by the string. So large int constructor in a toString are very important. Let's take the next slide and read further down. The third method apparently now is trying to implement add with input object obj and the returned object. So the precondition is returns this large integer plus obj and the post condition just like that. But the precondition is that obj of type large int. For the subtract, again, they receive the parameters object called obj and return object. So it returns this large int minus obj and its precondition will be obj of type large integer. Okay, the slide page 5 introduce a new method multiply. It also describes similar procedure, but this time it just returns this large int times object. Okay, finally, because we know that there are some comparable interface, so the Compareto method with input object obj and with return type int will need to implement it. This is the basic requirement. It wants us to return -1 if this large int is less than the obj, but if this large int is greater than obj, then we return 1, and if they are equal, the values, once we define how to compare the values of large int, then if they are equal, we return 0. Okay, question 26 is about of the following pairs of method which should be coded and tested. First, to facilitate testing and debugging the other methods. There are 5 methods. One is that the constructor and the 5 choices. The first choice is about the constructor and the add method. But you see, for the add method, if you want to check the performance or the content or what happens during these 3 methods, the add method, the subtract method, the multiply method, if we don't know how to print out for debugging, then there will be some problem. So that means that the toString method is the basic requirement for the debugging purpose. So let's check. And besides, we know that the constructor is important. So let's check out all these 5 choices, and it will be easily to find that the choice C, the constructor, and the toString method will be the 2 major important methods that needs to be implemented before we try to do the testing and debugging of other methods. They are very, very fundamental and helpful. So the choice is C. Okay, then we see question 27. Consider the problem of simulating the following loop for large int objects. What are they? Okay, it basically just want to do. Okay, this is an integer. We're starting with integer I equals to 1, and we increase I 1 by 1 until I less than n, and we print out everything. So that means we started by printing 1, 2, 3, and so on until print n minus 1. So because this is just an integer, but remember we just trying to define the new class called large int. So which means that once it receives the input parameters of type int, it will have to be converted into large. So what's the large integer versions of the for loop of this? Okay, you may assume that the n exists and is of type large int. Okay, now let's check the following for line. Large int I is equals to new large int 1, and large int 1 is equals to new large int 1. Note that this one is number 1, but the second large int called 1 is ONE. We believe that this means it's the basically added element of the adding operations. Let's check the while loop. The while loop says that while the I that compared to n is less than 0, then we continue to do something and we print out the values of I. Okay, then there is some statement that has been missed. So let's check which of the following should be replaced instead of a statement to simulate the loop correctly. Yeah, it's a very simple loops, but remember we have to switch between the basic integer I and also the large integer. Right now, I means a reference to an instance belongs to type large int. So if we want to add something one by one, we have to do the following. We want to add, and we have to define what does 1 means. Now, right now, the second line's large int 1 equals to new large int 1 goes into our consideration. That means we have to pass by this ONE as the basic adding element inside of this add operation. And after we pass that, we have to case it back to the large int. So that means the statement, this line should be like that. We will let I call the add method, and the add method will receive the parameter ONE, and after we call I.add of method ONE, we converted it back to large int, and after we converted it to large int, we use I to receive it because I belongs to type large int. Okay, so which of the following should replace a statement to stimulate the loop correctly? That should be choice A because we just mentioned. Okay, Okay, let's check question 28 and 29. Question 28 is a teacher needs to assess the reading level of a textbook, and one measure used is the frequency of words that have 6 or more letters. And a computer program scans the text and keeps track of such words and their corresponding frequencies by storing them in a tree map data structure. Now we're assuming that there are n different words in the key set so far, and which is the true statement about operations performed on those frequency maps. Okay, remember what is a tree map? Actually, if you remember your knowledge about the tree map actually is a very fundamental data structure. Underline this tree map. Actually, they implement a red and black tree of the input data. And we know that the red and black tree is a balanced search, a binary balanced search tree, right? So let's check. Once you know such a knowledge, we can check that the following 5 choices very easily. A. Insertion of a new word into the map is bigger of one, which is impossible because this only belongs to those hash map. The same thing happens, but we can easily to eliminate the choice C to update the frequency of an existing word in the map is bigger of one, which is also impossible if we talk about tree map, but not hash map. I mean, if we talk about hash map, then the choice A and the choice C are correct. But if you want to check the true statement, we don't have to consider this too. Now choice B says that to check whether a given word is in a tree is bigger of log n. This definitely belongs to the basic property of a binary search tree, especially this tree is balanced. So the best choice, the true statement is B. Let's check the incorrectness of choice D and E. Choice D says that to print a list of the key set of words in alphabetic order is big of log n, which is almost impossible because if we check the key set, we might assume that in the worst case, the key set might contain n different words, even though they might have, they might also have n different keys. So, which means that if you check, then at least the bigger of n steps needs to be done. So it is impossible that the print a list of the key set of words in alphabetic order is bigger of log n unless you can guarantee there be some redundancy between the key set and also some words that happens. We are uncertain about such information by the description of this. So we cannot choose choose D. But how about the choice E? To print a list of all word frequency pairs is big of log n. We can use similar argument to eliminate choice E. Okay. Let's check question 29. Question 29 actually is a basic question, but we don't have to be scared by this long paragraphs of the description. Basically, just trying to ask us how to implement and compare how to implement the inclusion operation. Okay, remember that in our study for the basic computer science discrete mathematics, that a set SET1 is said to be a subset of SET2. That is, set 1, which is a subset, equals to set 2. If there is no element in set 1 that is not in set 2. So we consider the is subset method below. There are following conditions. The precondition is that set 1 and set 2 are initialized with objects of the same type called sum type. And the post condition, it returns true if set 1 is a subset of set 2 and false otherwise. Now we want to implement the code of this is subset method of two input parameter sum type called set1 and also set sum type called set2 and returns boolean to check whether actually the set1 is a subset of set2 or not. Okay, The following are three different implementations, and we want to check which are the correct informations. Before we check that which one is which one of them are correct implementations, there is one tool that has been provided, which is called copy set to hash set. So it's trying to receive a parameter of set belongs to some type called S and return a hash set belongs to the same type. It might be used for just for the purpose of efficiency after we check the hash set. Okay, that means the size of the hash set that has been returned will be equals to the size of the original set S. But the checking procedure might be more easier if we do some adding, deleting, insertion, and also getting. So the implement one also trying to use this, take advantage of this copy set to hash set. So the first step is trying to copy everything belongs to set2 to some set of type temp. Then you use a for loop to scan through all some type of element belongs to set1 and let this temp gradually add all those elements belongs to set1. Finally, it checks that whether the temp.size is equals to the set2.size. Why is that? Actually, that means if all the elements instead of set1 belongs to set2, then they might be adjusted and maybe aligned in different sequences. But once we add all of them inside of this new hash set called temp, because all the set is keyword and also content, its keys and also content, the words, might has already been inserted inside of the hash temp. So that means after the for loop, the size of the temp will not increase anything if all those elements in set1 belongs to set2. That means as set1 is a subset equals to set2. If the size grows, then which means that there do exist some elements that belongs to set1 but that does not belongs to set2. So implementation 1 is a correct implementation. Let's check implementation 2. It's also the sum for loop for some type of element belongs to the set1. We check just the basically simplifying. If the set2 does not contain such an element, we return false. Actually, the logic of this if actually is the same as what we checked for the temp.add in the implementations 1. As long as we find one element that does not belongs to set2, we return false. But if we scan through all the elements of set1 and everything is fine, there's no false happening, there's no false event happening, then we know that the set1 is actually a subset, so it returns true. Okay, now we know that choice the implementation 1 and implementation 2 are correct implementations. That means we don't have to select choice A, we don't have to select choice B, and also we don't have to select choice C. We only have to check choice D and E. So let's check whether the third implementation is correct or not. This is a more complex one which has two lines of for loop. And in the first lines of a for loop, again trying to scan through all those elements belongs to set1. But inside of the inner loop, it also trying to scan through all those elements in set2. And as long as the element is for one specific element belongs to set2 is not equals to the element in set1, then we return false. Okay, let's see, is this a correct implementation? We don't know actually, because this for loop, this double levels of for loops will scan through everything belongs to, it will try to pair every element of set1 with the element of set2. So for all those elements, E belongs to set 2, there might be only one choices that it has the same element in set 1. So which means that the inclusion only holds once. But if we scan through other elements belongs to set 1, which might not equals to element E in set 2, and such kind of returning false will lose our choices to check the exactly correctness of two sets. For example, if set 1 has 1, 2, 3, and set 2 has 2, 1, 3. Now if we scan through 1 with 2, because the first element of set 1 is 1, the first element of set 2 is 2, then this if element will return false. But actually they are just represented in different sequence. Actually set 1 is a subset of set 2. So choice D is the correct answer because we don't have to consider implementation 3. Okay, so thanks for listening to this video. If you are more interested into getting more efficient ways to answering the questions of AP Computer Science in AB level, you're welcome to continue subscribe to our channel, the videos in our channels, and also you are also welcome to discuss with us in our channel and also in our website. And thanks for listening. Hopefully we will meet you soon in our next video about AP Computer Science. See you.